One-way ANOVA. One-way ANOVA hypothesis. Here you have the null, which is always saying all the means are equal, and the alternative is saying not all the means are equal. Okay, so let's take a look at when to apply the one-way ANOVA. One-way ANOVA. What's one-way ANOVA? One-way ANOVA, one-way analysis of variance. Okay, that's the name for it. ANOVA is abbreviation for analysis of the variance. It's a statistical method for testing for differences in the means of 3 or more groups. So whereas the independent samples t-test and the paired sample t-test deals with 2 means, exactly 2 means. If you are to compare 3 or more, you can use a one-way ANOVA. And how is one-way ANOVA used? One-way ANOVA is typically used when you have a single independent variable or factor, and your goal is to investigate if variations or different levels of that factor have a measurable effect on a dependent variable. So when we go back to our example now, here we have, it looks like the factor is type of vehicle, and the dependent variable here is mileage. So you have 3 different vehicles, and you want to compare the average mileage of mid-size vehicles, sports utility vehicles, and pickup trucks. So the null will be saying that the means are all equal, all 3 of them are equal, whereas the alternative is saying not all of the mean mileage of mid-size sports and pickup are equal. So here's the case scenario. It says medical researchers want to know if 4 different medications lead to different mean blood pressure reductions in patients. They normally assign 20 patients to use each medication for 1 month, then measure the blood pressure both before and after the patient started using the medication to find the mean blood pressure reduction for each medication. To understand whether there is a statistically significant difference in the mean blood pressure reduction that results from these medications. Okay, that's 4 of them, eh? So that's more than 3. Researchers can conduct a one-way ANOVA using type of medication as a factor and the blood pressure reduction as a response. Because for one-way ANOVA, you must have a qualitative independent variable called a factor, and here it is type of medication, and a dependent quantitative variable, which is blood pressure reduction in that case. So if the overall p-value of the ANOVA is lower than our significance level, we can use 0.05, then we can conclude that there is a statistically significant difference in the mean blood pressure reduction between the 4 medications, because the null hypothesis will be rejected, and you conclude with the alternative, which is saying that there is a significant difference in the means. So we continue with the research topic, which is with regards to the population, type of medication, and blood pressure reduction. Research question, which is again directed towards the population. Is there a difference in the blood pressure reduction due to type of medication in the population? So anytime we talk about the research question, and the research topic and question is about the population. Now the hypothesis now, which is a response to the research question without empirical data, again directed towards the population, says that, or claims that there is a difference in the blood pressure reduction due to medication in the population. So this is a hypothesis to be tested, okay, to determine as the objective, or to find out if there is a difference in the blood pressure reduction due to medication in the population. So although the claim or the hypothesis is saying that there is, it is yet to be determined, okay, which is the hypothesis test called one-way ANOVA. To test this type of hypothesis, data has to be collected from the population. A sample has to be taken. Which is blood pressure reduction, okay, across the 4 different groups for each type of medication. So here's the data that was collected from the sample of the blood pressure reduction due to the 4 different medications. So here we're going to follow the steps for a p-value approach. Step number 1 is to state the pair of hypotheses. And the null will always be saying that there is no difference between the means, and the alternative will always say at least one mean is different. So the null is written symbolically, making use of the symbol for population mean. And as you can see, it is saying that all the means are equal. There's no difference between the mean blood pressure reduction, whereas the alternative is saying that at least one mean blood pressure reduction is different. Step number 2 is to input the data into an appropriate calculator. Again, we are going to make use of statistics kingdom for ANOVA calculator. Our significance level continues to be 0.05, and we are going to enter the raw data directly by copying and pasting from our document. So we'll start with medication A, copy. We have to copy individually. Medication A. So that's groups. So we need 4 groups, so we have to add and insert an extra column. Right, and this group 1 is medication A. And we do the same for medication B, C, and D. Now we have input our data in the calculator. We are going to calculate. So we just type calculate. And what we need to do now is to identify the p-value, okay, which is the next step. And here it is, the p-value, 0.8043. So step number 3, that's a judge or jury referee, the p-value, which is 0.8043. So it's a judge or jury or referee because we have to use it now to state a decision. If the p-value is less than the significance level, which is 0.05, then we have to reject the null hypothesis or the null statement. And if the p-value is not less, or if it is greater than the significance level, we do not reject the null hypothesis. So therefore, now, since the p-value of 0.8, that's huge, 0.8043, is greater than the significance level of 0.05. Okay. We do not reject null hypothesis. And conclusion, if the null hypothesis is rejected, then the alternative is the conclusion. But if the null hypothesis is not rejected, itself is the conclusion. So therefore, since we did not reject the null hypothesis, The null hypothesis is the conclusion. And what the null hypothesis is saying, the null hypothesis is saying that there's no difference between the mean blood pressure reduction across type of medication. So hence, there is no difference between the mean blood pressure reduction due to type of medication. The difference is not significant, in other words. There's a slight difference, but it is not significant. And if we take a closer look at the data, I purposefully made the difference very slight. Okay, 13, 10, 21, 23, 14, 18, 10, 14, etc. So although there is a difference, it is not significant, and the test has proven so, which of course, it goes against the claim, because the claim is saying that there is a difference. So in conclusion, the claim is false. And that could be a type 2 error because we did not reject the null, and it could be false, okay? So if this is so, then we could have made a type 2 error, not rejecting the null when it is false. But this can only be proven if another test is made and a different conclusion. Okay, if the test is repeated with different conclusions, then we would have detected an error type 2 have been made, since we did not reject the null and it could be true. And just to reiterate, we did not reject the null because the p-value is greater than the significance level.